That's right, folks. It's John Pushkar from Prescient Technical Services, back here today as the captain of obvious fuels and fired equipment hazards. Yes, my public has demanded that I show up in uniform. I'm sorry about those previous episodes where I wasn't in uniform, but it's okay. I've even got the little hat on for you here today. Although I'm intending for this to be interesting for you, there's, again, really nothing funny about some of the things I'm going to cover. They're very serious hazards. I'm glad I've got your attention, and I hope that I could maintain that attention for the next 10 to 15 minutes. You'll learn a lot. Any one of the things I'm going to show you can save someone's life. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. Prior to viewing this episode, this was probably not an obvious problem to you. Hopefully, from this point forward, this becomes a very obvious problem to you. I'm hoping that from now on, when you walk past a pressure switch and you see some type of a set point indication, you'll look to make sure that you're not set all the way to a minimum or a maximum position. This is an airflow proving switch, and it's set to a minimum position. It shouldn't be installed that way. Most likely, because of some defect in the system, maybe the fan's not moving as much air as it should, or there's some problem with the airflow path, someone has reduced this setting to its minimum position. It's likely this is not where it's supposed to be, or the switch has been selected wrong. Both are obvious problems. Here's another one, a fuel pressure switch, and you could see that this one's set to its absolute lowest position. Again, an obvious problem. So what do you do about switch set points? Well, the actual set point you're supposed to achieve for safe operation is not provided in the little box that comes with the switches. No, this calls for something to be commissioned or recommissioned. You have to have someone who knows how to adjust fuel-air ratios and firing rates of burners. This is not for amateurs. Setting the low fire gas pressure switch means operating at the minimum expected firing rate and then making adjustments to the gas pressure to see when the flame gets unstable, then resetting the switch, and it's the opposite at the high end. Someone's going to have special knowledge, experience, and instruments to put into the flue gas stack and have access to view the flame and maybe the flame signal strength to be able to do this correctly. And once you have the proper set points, make sure you document them somewhere and also put it right on the switch. Get yourself a label maker of some point or a Sharpie marker, mark the set point, write that on the switch. Obvious issue number 2. Make sure that you remove switch covers if you have this kind of a switch and you can't actually see the wiring terminations, and understand what's going on inside the switch. Now, Ashcroft's a very high quality switch and use all over the industry, all over the world, but even they can't prevent people from doing stupid things with their product. So here's one of those switches. When you remove the cover, you could see, wow, what's been going on inside of here? Tons of corrosion going on inside. I don't know if this particular switch was outdoor rated, but quite possibly, if this has been opened up before, someone didn't install the gasketing properly, and this is what was left inside. Obviously, this switch did not function. And here's another one that's actually been bypassed with the popsicle stick that someone inserted and broke off in the switch to hold this airflow proving switch open. Again, a very dangerous condition because you possibly didn't have the right airflow. Frankly, you could have no airflow. So you wouldn't get a good purge, you'd have a very unstable flame, and this could be leading to quite a catastrophe. And even here, this is a different style and type of switch, but this airflow switch did not work. So what did somebody do? Instead of replacing the switch, they terminated both conductors on the same terminal, so this switch would be seeing continuity all the time, regardless of the airflow conditions. Obvious issue number 3. You might have switches installed within your systems that actually have mercury in them. Mercury is known to be a hazardous material. You should be careful if you're servicing these, carrying them around, trying to dispose of them. They should not go in the trash. And many organizations are on a mission to rid themselves of mercury. So again, if you have these in switches, this is possibly something to report, something obvious that you should be aware of. Here's another style of mercury switch. You can see a little glass tube in there. So what actually happens is there's 2 conductors placed side by side on one end of the tube. In this particular style of switch, that glass tube with the mercury tilts when different set points are achieved. So when the switch is made, mercury rolls over those 2 contacts and makes for continuity through those 2 wires. One of the little obvious things you should be looking for also in mercury switches is the thing installed level? It's so important that these things be installed level because it changes the accuracy of the set point that you have, that there's actually a little pendulum, a little target mechanism you see there in the white box. That's pointing down at a little indicator. That's put there so that you can help determine that the switch is installed level. So again, it's an obvious way to look at how the switch is installed and see if it's installed properly. Here's a close-up inside one of these switches with the cover removed. Now, they don't all have this, but if they do have this, you should take a look and make sure it's installed properly. Another thing you should be looking for is isolation valves installed on pressure switch impulse lines. This is a no-no. It provides a means for you to mechanically bypass these kinds of pressure switches. Now, there are folks who install 3-way vented pressure switches for use to accommodate testing. That's what I'm showing you here in the picture. This is very rare. Only a few organizations I know have subscribed to this. But the more common problem is that someone has installed an actual isolation valve, a little ball valve typically, that can be used. Sometimes they'll claim it's for calibrating these switches, but quite frankly, if it's left in the closed position, you've in effect bypassed the function of those switches. Here's an example of someone who's installed an isolation valve in the sensing line and the impulse line to a pressure switch. You can see the little ball valve installed there. Again, unless this is locked open, it's really something that frankly shouldn't even be there. Number 5, do you understand that many of these switches are purchased with a manual reset option? Do you know, is it obvious to you how to reset these switches? So on the right-hand side of this switch, you'll see a little rod sticking out. That's actually the manual reset mechanism for this type of switch. So if, for example, this was a low gas pressure switch and someone had shut the gas valve and you went off on low gas pressure, you might not be able to restart unless this rod is then pushed in and the switch is reset. Likewise, if it's a high gas pressure switch, it might have a mechanical reset. Might be a rod, might be a button, but it should become obvious to you so that you can troubleshoot your equipment where these resets are and what form they take. Again, different style of pressure switch. You see the little black button below my picture there? That's the reset switch. This is kind of nice. It's a high steam pressure limit switch, and there's even a little placard there that tells you manual reset on top. Now, of course, if you do have to reset a switch, it's indication that something went wrong. Could be a very dangerous circumstance. So it's incumbent upon you to investigate first. That's why these things have manual resets. It's so that you don't continuously recycle this device with a very dangerous condition occurring. Like, for example, if it's a high gas pressure switch, maybe the regulator has failed, stuck open. You don't want to keep firing the thing and relying on the manual reset to work. You could have a catastrophic event occur. So be very careful with understanding how to do this. If you're not experienced with this kind of equipment and you do find a manual reset tripped, maybe you want to go get somebody involved who is designated as your combustion expert or someone who's got a lot of experience with this type of equipment. Remember I talked about switches in the impulse lines? Well, you also have to observe the condition of some of these impulse lines. If they're obviously kinked, we're restricting the flow through the impulse line, the switch won't work correctly. So take a good hard look at the condition of impulse lines. How about these? Pretty obvious these impulse lines are not in a very healthy condition. And remember, any switches that you should select, they should be compatible with, first of all, where they're installed. Are they indoor or outdoor rated? What about the type of material that we're going to be using them for? Using them for natural gas, not a big deal. But if you've got biogas, for example, or some other type of industrial blended type of gas, you might want to make sure that the seals within the thing are compatible with what you're using it for. And then, of course, addressing the pressure rating is a very important thing. Remember that everything installed in a fuel train has to be rated for the pressures that it might see. They also have to be rated for whatever pressure is upstream of the nearest regulator. So in case that regulator fails, you don't fail these devices as well. Many pressure switches on fuel gas systems are installed with vent connections. If the manufacturer has provided you with a vent connection, according to the standards and codes that apply, you're supposed to take piping from there and run it to a safe place. Now, I will tell you there are many styles that are sold that are unvented. These are obviously much simpler to install. You don't have to deal with vent piping. When it comes to pressure switches for steam boiler systems, many of them have to be protected from direct steam impingement onto the underside of the diaphragm mechanism. The manufacturer's instructions typically call out that they be installed with a little pigtail device called a siphon tube. Generally, there's water poured into the siphon tube so that water presses up against the diaphragm and not direct steam. If you don't do this, you'll never get the maximum expected design life of a switch like this. You'll find them quite often failed prematurely. And last but not least, let's talk about the covers that appear to be somewhat decorative that are installed on many pressure switches. This is called a Bourdon tube type of pressure switch. In here is a very thin, delicate tube, and that glass bulb there is installed on the end of it. So when this tube sees more or less pressure, it changes shape. However, if you rupture the tube, gas will escape inside behind that plastic cover. That plastic cover is there to direct any leaked gas towards a vent pipe. So it's very important that these plastic covers remain and be installed and be intact. Likewise, you'll see on this particular Honeywell gas pressure switch, you'll see a glass cover and a gasket behind the glass cover. It'll be really obvious if this is missing, and if it's missing, it needs to be replaced. It is a safety hazard, and now you understand why. Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being the legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.